Solid hemisphere, okay, half lemon. What about hemispherical shell? You take some volleyball or basketball, cut into 2 equal parts. So what do you get? You'll get like a ball, no? Hemispherical ball. Therefore, where the charge is present? Only on the surface. Charge present on the surface. Not throughout the volume. Charge is present only on the surface. Charge. Let me write it, because once you will get an idea of what is the hemispherical shell, it will be much easier. The mathematics will help us a lot. Charge present on the surface. Okay, come for this one, no? Now, what is the method here, no? Where the charge is present on the surface. So what we write? Charge density sigma equal to Q by 2 pi r square. What is the surface area of hemisphere? 2 pi r square. Charge is present only on outer surface. Charge present on the outer surface. What is the method? I'll assume an elemental ring. So what we have is, this is an elemental ring. Elemental ring of radius r. Come for this one. So I assumed a elemental ring of radius r. Radius is small r. Then what is the slant length of that? Let it be dl. dq is the charge present, and dA, let it be the surface. So what is dA? How you define surface area of this elemental ring? Area of elemental ring. Area of elemental ring. That should be equal to dA is equal to 2 pi r, circumference length 2 pi r into the width will be dl. So from the diagram, what is sine theta? Small r by capital R. Okay, I agree this. So where all sine theta is there, I can write it now. Sine theta is equal to small r by capital R. I'm asking you to look at this part. What is sine theta? Small r opposite by hypotenuse. Small r by capital R. So in place of small r, I'll write r sine theta. So therefore, this should be r sine theta. What is dl? dl is the arc length. This part. What is dl? Equal to r d theta. So 2 pi r square sine theta d theta. So we have cos theta will be adjacent by hypotenuse. Sine theta opposite by hypotenuse. Charge on elemental ring. dq is equal to sigma into dA. So what is the sigma? Already like a dA is what we have brought it, no? Expression 2 pi r square sine theta d theta. That you substitute here. Okay, now charge on elemental ring is what we are able to find out. Okay, what is the electric field strength at point O? So this will become like an axis. The vertical line, which is passing to the center of hemispherical shell, will become an axis. So what is the electric field strength on the axis of the ring? The formula is K dq x by under root of r square plus x square to the power of 3 by 2. Comparing that with the ring. What is x? X is the distance from the center of the ring to the point O on the axis. What is radius of the ring? Small r. Capital R is radius of shell, hemispherical shell. Small r is radius of the ring. This is the formula. Okay, let's substitute all. dq is equal to how much? Sigma 2 pi r square sine theta d theta. Some of you are getting confusion. I'll do one thing. Let me help you. If this is the what will be the electric field strength due to the ring? So charge is dq. So what will be your formula? E naught equal to K dq x by I'll write it below. I'll write it below. dE naught equal to K dq x by can you remember this? This is like an axis. It's a ring. So the same thing is what I wrote it here. Fine. This one. Okay, let me substitute dq. Green color I did substitution. What is x? Further x equal to r cos theta from here. So in place of x, I wrote here r cos theta. Then what is small r? Capital R cos, small r equal to capital R sin theta. What is x equal to? Capital R cos theta. Then r sin theta whole square plus r cos theta whole square will become only r square. R square and r to the power of 3 by 2 will get r cube. Then here we have r square and r. So the product of that will become r cube. So these two r cubes will get eliminated. That's what happens in the next step. Then sin square theta plus cos square theta will be 1. Okay, this and anything to the power, any power to the like a 1 to the power of 3 by 2 will be 1 only. So in the new denominator will end up with 1. Now further you look at this 2 sin theta cos theta d theta. Can I write it as sin 2 theta? And r cube get cancels. So what will be left over here? Pi sigma k sin 2 theta d theta. Let me integrate it 0 to pi by 2. The limit 0 to pi by 2. So substituting this one minus 1 by 2 cos 2 theta upper limit and lower limit. So cos 2 pi, what is upper limit? Pi by 2. So 2 pi cos pi will be minus 1. Cos 0 will be minus 1. So solving that will end up this one. So what is further? The k is. So what is a electric field strength? Sigma by 4 epsilon naught. This will be your answer. Hemispherical shell, solid hemisphere. Solid hemisphere,